Good afternoon, Howard Wig, Code Green Think Tech Hawaii. I am honored to have today Michael Hallinan, Director of Sales for Pacific Industrial Coatings. Now, how intriguing does that sound? Actually, it is very, very intriguing, very important industry for helping Hawaii to meet its goal of 100% clean energy for electricity by 2045, which is only, 29 years away. We'd better hurry up and get doing some things. And Mr. Hallinan is going to tell us, I presume, how with his product we can vastly reduce energy use, air conditioning use specifically, in both commercial buildings and residences. And at the end, we'll throw in not a brand new solar water heating system, but a new approach to solar water heating for residences that I personally was not familiar with. So there's another angle there. So let me give you a little background, since I'm in the energy codes field. The typical energy use, if you divide a energy use pie for your typical commercial building, either your number one energy user or number two energy user, actually it's number one since LEDs are coming in now, will be air conditioning and all the fans and all the water that is pumped around to keep the building cool. Why does it have to work hard? Because we live in Hawaii, and here it is the middle of winter, and we're still air conditioning like mad, as we do every day of the year. The more we can retard that heat or even eliminate that heat from coming in the building, the easier is the job of the air conditioner. Major, major, major savings potential there. So welcome, Mr. Hallinan.
Thank you.
And Mr. Hallinan's been in Hawaii for 17 years approximately.
About that.
And very, very, very happily ensconced here. So let's begin by looking at your product here.
Sure. Yeah, that's a closed cell polyurethane foam to basically the wood underneath would be representative of a substrate roof based the top of the roof system, whether it's cement, wood, metal, whatever it might be. We spray a closed cell polyurethane foam, usually spray about 1 millimeter. That rises like a cake to about an inch. And then we cover that with a silicone on top with 95% solids commercial grade silicone. And then that becomes our full roofing system.
Now I have to do a little English translation here. There are a couple of different roof coatings. You've seen in the newspaper a person on a roof rolling down a white coating, and it'll say, next to the old dark coating, and it'll say before 178 degrees, after I think it's 105 degrees. This huge, huge, huge temperature drop. And I know there's a difference between acrylic coating and silicone coating, and I believe silicone is probably more expensive, but I know from personal experience that it is really, really rugged, really durable. And correct me if I'm wrong, but it's a very smooth coating, and the smoother any surface is, the less inviting it is for microbes to attach there and turn this nice white first to a grayish, then a greenish, and then during the sun, all that nice greenish microorganisms turn black, which kind of defeats the purpose.
Yeah, the nice thing about silicones, it is water resistant. It repels the sun, so it doesn't break down from the UV rays. It allows you to power wash it at any point in time if you want to bring it back to the bright white it was before. So if for whatever reason it does have a issue with turning brown, or maybe from leftover soils or anything that might be left over in rainwater, it's very simple to bring it back to a true white again. The thing about being smooth, the way our product's applied, it's going to mirror whatever surface we spray it on. So not that it's that every time it's going to be absolutely smooth. It really depends on the substrate that we're spraying it onto. So if it's a gravel roof first and we're having to remove the gravel, we may not be able to get it all off. There may be a few spots that rise, so it may not be absolutely level, because remember, it's going to mirror. we do our best to sand down some of those areas before we apply. And we actually do put a base coat in to protect the closed cell polyurethane foam before we actually apply our silicone. And we try to do as much 4,000 or 5,000 square feet a day, depending on the project, and set it up so that one day we spray and top coat, or spray and base coat, and then the next day top coat. So we do a process, so it really does repel the sun and keep it cool.
And let's see, just to translate into English again, this stuff is the foam, and it doesn't look like the foam that you whip up when you're whipping milk or anything.
No.
Milk would be extremely low density foam, and then there's some insulation materials that are low density. This, I gather, is high density?
Yes, it is.
Yes, and high density means the molecules are really, really, really close together. What is the advantage of high density versus low density in the foam?
You know, mainly from the standpoint of strength and the actual closed cell, it really only is a high density type product in the application process. It's an A and B product when they come together. So it's actually two separate tanks of two different materials. And when they're sprayed through the system and applied onto the roof, they actually rise and then set. So it really is geared toward a roofing type application. There are other type of foam that's open cell that we would use more of an internal interior space.
For walls or for attics or?
Correct. Correct. And then also the roof spray foam is a 3-pound in nature versus a 1/2 pound for open cell or a 2 pound for closed cell for interior. So it's a little denser product.
Denser, and so the 1 pound, 2 pound, that refers to cubic, certainly not a cubic foot, a cubic inch, or?
It's probably my weakest spot when it comes to breaking it down into that level, but it's a density of product per square inch. And so it is designed to be denser, really extremely strong. You can put a lot of pressure on it and not even dent it. So that adds that rigidity value to it. And especially when we apply it to commercial roofs, that last 4 feet has the best bond there is of any product to keep any uplift that may happen on a roof system.
And by pressure, we could mean the pressure of a human foot.
Correct.
People have to get up there and do work on the HVAC system.
Yeah, and many times there's ballasted systems that get put in place for solar PV that they want to have a racking system built with weights on it.
Yes.
They can withstand that type of pressures.
Yeah, one of the state buildings downtown is the Kalani Moko building, corner of Beretania and Punch Bowl, and they had a ballasted PV system put up there. And I know they needed a civil engineer to go up and analyze the roof. Can it really handle all this weight?
Certainly.
And so forth.
And we have plenty of jobs. I think the Servco in Mapunapuna has our product underneath a ballasted system that was installed by one of the local, I think Synetric installed that application. And so many collectors up there. And the reason why they did it is they wanted to move the system in 15 years, and having a ballasted system allows them to move their location and bring it with.
Another English translation necessary here. Most photovoltaic systems are anchored to the roof with great big bolts. You have to figure out what in the infrastructure is really, really solid under there, and you put these great big bolts. But some people don't want to do that. They want to have a ballasted system, and we're familiar with the ballast of ships and things great weights that you put in the bottom of the ship to keep it from rolling too much. So in this case, these are something that are really, really heavy that you put down and firm. And you know, as we learned from last summer, the hurricane is not if, it's when. So I presume that these ballasted systems are.
Yeah, I think they handle up to 120, 140 mile an hour wind rating when they designed a weight that's actually going to be applied. And you know, the tilt makes a difference, and how much elevation off the roof level makes a difference. So there's an engineering skill that the applicators have to go through to make sure they apply the right amount of weight for the amount of uplift that may happen.
So this is really rugged stuff.
Yeah.
And now you happen to have this little protrusion coming up here. What is that all about?
Yeah, well, that's to represent, like, it could either be a penetration from a roofing system for a PV system, or it could be ventilation for any type of pipes or anything that might be coming up of the roof. It could be just about anything, like a racking system for HVAC, anything that we want to mount something to the roof or allow ventilation to the roof. So what we do is make sure that when we apply our product, we seal it around the edges. And I'm not sure, I think I might have to turn that a little bit. You can see that we'll actually apply a little of the foam around it. And in many cases, we'll actually build a cocoon, like a little volcano, if you will, around it to make sure that there isn't any areas that may be lower to keep any buildup to come back at it. And then we'll coat all the way to the top of whatever unit that might be there. It could be a standoff for solar or pipe or fitting, and we bring it to a minimum of 4 inches off the roof, and depending on how much higher it is, depends on how much higher we'll bring it up.
Yeah, so that if there's a horizontal rain coming at it, it won't creep behind any coating like that.
Exactly right.
But you know what? I've been so fascinated with this little piece of equipment that we are completely neglecting our slides. We haven't done a proper introduction here. If we could get slide 1 up here, Terry, then we can use that as our talking points. Okay, Pacific Industrial Coatings, and well, why don't you explain?
Basically, the 3 primary things that we came here to talk today about is our spray foam roofing system, which is what we've been talking about. It actually shows an applicator actually spraying onto a gravel roof. That's what's in that display. The middle one would be a solar hot water system that's more of a passive system that we'll talk about toward the end. And then also the interior foam spray that we're using, which we also briefly talked about, the difference between a 3-pound, 2-pound, and open cell half-pound product. So we're finding that more and more people are putting air conditioning in their homes and wanting to find ways to reduce the heat, as we started out the introduction today. And you know, certainly putting the foam on the roof is kind of unique, but having the interior foam versus a fiberglass is a much better way to seal up the envelope in that space.
Yeah, and speaking of sealing, I've watched foam being sprayed on the interior, and you don't realize it, but there's all this framing, and then there's the electrical outlets. There's all kinds of things going on in a residential roof or a commercial wall or commercial wall. And you can, with a skilled sprayer, he can go all around those penetrations and get every cubic centimeter totally sealed.
Absolutely.
Which is what you want.
Yeah, we're definitely an applicator that the manufacturer trusts in our abilities, and we're able to give a manufacturer's warranty on many of our applications that we do, because we do have the skill level. Over 35 years from both our 2 owners in the industry, both as the manufacturer's rep and applying the product. Yeah. And it does take quite a bit of time to get our applicators to a level that skill that I think we're up to 29 or 30 employees right now, and about 3 to 4 crews depending on the application.
Great. And what do we have here? We have, well, let me just comment on the person on the right spraying under a roof. I watched this being done once at a job site. It was fascinating. As you were referring to the level of skill, the sprayer will spray, it looked like, as little as a ½ inch of this viscous material on, and then just like magic, it goes out. In this case, there were 4-inch studs, and it just went right out to about 4 inches. And they are trained to do that because this stuff is not cheap. You don't want to be getting too much and then have to scrape off a lot of excess.
Yeah, it definitely takes a skill, and the applicators will actually test the temperature and the pressures that come through our equipment. Each one of our rigs is not inexpensive. They're about $150,000 to apply the actual process to put it in the space. But you know, like you were saying, if it's ½ foam and they spray about a ½ inch, they'll get about 3.5 to 4 inch rise off of it. And so we'll actually come back in interior walls and cut that back with a knife, and actually allows the leftover material, and we try to keep that material down as much as possible to save money,
Yeah.
just as you described.
Yeah,
So,
because number one, it's not cheap. Number two, now you have something headed for the landfill, and that's not good for anybody.
yeah, and there's additional product that we have to add in anything that goes on the roof for fire code. It's a fire stop type product. We have one of our products that has it built in. So as we apply it, it actually will have it built into the foam.
Oh.
The half-pound version is most popular for that.
I sit on the Hawaii Building. We'll be back in a minute. Think Tech Hawaii Code Green.
Hello, I'm Stephen Katz, and I'm the host of Shrink Wrap, which comes to you live every Tuesday at 3 p.m. on thinktechhawaii.com, and then it's repeated again whenever you want if you go to the website. On our show, we will be talking to all different kinds of therapists, psychologists, psychoanalysts, psychiatrists, people who talk about the mind, the brain, and about different ways to find happiness. I myself am a marriage and family therapist in practice here in Hawaii, and I hope you will join us because I've got a lot to learn, you've got a lot to learn, and it's a great ride. Thanks a lot. See you soon.
Aloha, I'm Kaui Lucas, host of Hawaii is My Mainland, here on Think Tech Hawaii every Friday at 3 p.m. We address issues of importance for those of us who live here on the most isolated landmass on the planet. Please come join me Fridays at 3 p.m. Mahalo.
Good afternoon again. Howard Wigg, Code Green Hawaii. Very honored to have Michael Hallinan, Director of Sales, Pacific Industrial Coating. And we got so carried away with this sample product. This is just the type of stuff I love, that we need to proceed with our slides. If we could have the slide 3, and then we'll use that as our point. Reduce operating costs. We talked about reducing the HVAC costs, but in the break you and I were talking about, was it a lifetime guarantee or a many, many years guarantee?
It's a sustainable roofing system. It really never has to be replaced.
Yeah.
So it truly is a product that can be, once it's in place, installed properly, never pulled back out or torn out again or replaced. So it's not necessarily a guarantee, but it's the design of the system that allows for it not to have to be taken out of whether it's interior space or on the roof. So one of our installations from one of our owners is Chateau Ste. Michelle Winery. They have a warehouse that was done 35 years ago.
Ooh,
and,
old technology.
Yeah, and they spray, and that's how long this closed cell foam has been around, actually. And so they applied the product and put in a silicone, and that's one of the only roof systems that they have that's never has to be replaced. So in their list of property and what has to happen in maintenance, it has an indefinite roof life.
Yeah.
So they were the first ones to kind of validate the fact that it really never has to be torn back off or reapplied.
And temperature control in a wine warehouse is a rather critical factor here.
Yeah, generally 10 to 15 degree drop on whether it's air conditioned or not is the traditional type of reduction in temperature you should see. So we see that all the time. In fact, we get a lot of comments, especially on our metal roof customers here, that when we apply our product, they just see a dramatic drop. And we actually did the Bank of Hawaii over here, and we did one of their processing facilities, and they had to come back and retool all their air conditioning systems because it was so much cooler after replace the system. They had to engineer the flow and control
That's
their
music
temperature.
to our ears, because the lower you can set the AC, the less energy, the closer we get to Hawaii energy independence, and the more money is in people's pockets, and the less oil we import.
Fantastic.
Sounds like a triple or a quadruple win to me.
Absolutely. So looking at the slide, that LEED certification is something that comes up more and more often. We do offer a closed cell that has an R value of 6.5 for every inch for our closed cell foam. A lot of our architectural new building construction customers are coming to us, and we're adding value to redesigning the roof with our closed cell foam instead of the traditional roofing product.
Now, so 6.5R, R stands for resistance to heat transfer. So this would be close to 2 inches. So this would be at least R12 or something. But we've got this on top of it.
That adds another layer of reduction in
Because
energy.
we're talking, and I know absolutely, we're talking a temperature drop compared to a dark roof of at least 40 degrees, if not 50 degrees. So all of this would almost seem to be overkill because this is nice and cool up here.
Yeah, and it's funny that you bring that up because we've got customers that ask us for, being that they're mainland designers building some of these buildings, they want an R value of 30 to be applied on these roofs. And we have very few roofs that we apply more than 2 inches, inch and a half is pretty common in our installations because we just don't have that temperature flux that they do in the mainland. Our temperatures are pretty consistent.
Yeah, and we're concerned only with keeping the heat out, not with keeping the heat in during the winter.
Yes, so we usually have to work with them a little bit to have them show some models that reflect the fact that we don't have those temperature gains.
Reflect the fact, get it? Reflect the fact, yeah. So I'm the energy codes guy, and we have a new energy code coming up, 2015 IECC, which will require R38 in commercial roofs, but we have made a special provision for reflectivity.
Oh, great, wonderful.
Yeah. So LEED certification, many clients want that these days. And what else do we have in the way of slides here?
Yeah, the next one should be about the spray foam installation and more of a soundproofing environment, or it uses, in this particular size, it uses it saves up to 50% of energy in cooling, and we've seen that many times, like I just mentioned on the Bank of Hawaii, by applying the interior foam on the roof, or the closed cell foam on the roof, that we've been able to drop the temperature enough where they've reduced the amount of HVAC that they've needed to fill the space by 50%.
And just incidentally, talking about foam, you mentioned soundproofing. If you get into the walls, very important in many commercial spaces.
Absolutely.
So it's soundproofing there, yeah.
Our half-pound open cell product is ideal for that. The 2-pound closed cell isn't so great. It's so dense that it does not reflect. You have a lot of sound reflection back, so you're not reducing the sound, but the open cell allows for that to happen.
Yeah, there's more airspace into there to absorb the sound.
Yes.
Yeah.
So one of the big things, if we skip to the reducing the urban heat island in Hawaii effect, maybe you know a little bit more about this. This is something I'm just getting exposed to. But basically, buildings that are built into the infrastructure of a city tend to be a higher, anywhere from 1.8 to 22 degrees warmer than the surrounding areas. And so by applying our products, both the roof as well as the interior foam, you greatly reduce their energy costs.
One of my favorite toys is a heat gun, where you point a laser at a surface and it'll record the heat for you. I've done experiments with shooting a dark surface with the sun radiant heat directly on it, and I'll get a temperature of something like 150, 160 degrees, and that's generally a dark, rough surface. Then I go to a white reflective surface right next to it, side by side, and I will get a drop of at least 35, if not 40 degrees. And that's side by side.
Certainly.
Right there. And so, and then just the urban heat island effect, the further you go from a city, the more vegetation you have, the grass and trees, and those by themselves have a cooling effect with transpiration plus shading. And so you do have this great buildup of heat, as the chart really showed nicely, but instead of absorbing that solar heat and keeping it in there, the reflective surface will radiate it right back up to the, not just the atmosphere, but to the troposphere. And I deal with Lawrence Berkeley Labs outside of UC Berkeley, and they're specializing in emissivity and urban heat islands. And this is going to be a major push in the future, because worldwide people are migrating from the countryside into the city.
Great.
And the more clusters you have, the hotter it's going to get. Couple that with global warming, and we've got a little problem here.
Yeah.
And so reflective surface is going to be a really, really important worldwide solution.
Yeah, and again,
down
with
the
the
road.
silicone that we use, it does last a lot longer. It doesn't need to be reapplied, where acrylic can break down about 2 millimeters a year
yeah.
and has to be reapplied every 7 to 10 years. So having just that coating in discussion, having a product doesn't break down to UV and is 95% solids or in a commercial grade level, it'll last as long as it is applied on the roof and isn't damaged, of course. So.
I have experimented with both types, and I can say from literally not dirt under my fingernails, but white coating under my fingernails, that is absolutely the case.
Yeah.
Let's see what we have. A next slide coming up, very interesting. So we have, I guess this is a view of a city.
Yeah, actually, it's a space. It's a warehouse, and on the left-hand side is before we applied our product, and on the right-hand side is after.
Yep.
So you can see the rafters and the support trusses and everything that's kind of just like you said, using a ultraviolet type camera to get that heat reflection. We were taking readings on both sides, so you can see the big gains that we see in temperature drop. You just illustrated earlier. In this case, it's well over 50, 50 F
over
drop.
50 degrees drop, yeah.
Yeah, so it's simple to be applied, and it's really a great application to reduce your overall energy costs by dropping the heat from the roof first. That's where the sun's going to hit right off the start.
And you mentioned longevity, which is important to us. We also consider something called resource efficiency, where just take a light bulb example. The old incandescent lasted only 750 hours. Take it out, replace, take it out, replace, take it out, replace. The new LEDs are going to last at least 50,000 hours. They're just going to be there.
Yeah.
So you had to manufacture it only once, and you don't have to duplicate that, and the disposal costs are going to be virtually zero. In the case of your product, the disposal cost is going to be virtually zero also.
Yeah, and the more that we have, of course, the higher our value. So especially when you're applying it to the interior under the roof. So the thicker, the less heat transfer you're going to have coming, reflecting back through. So that was the main on that illustration, if we want to keep moving forward.
Yeah. And what do we have next here?
As far as it's
Re-roofing, yeah.
Because it's a sustainable product, like I mentioned earlier, it doesn't ever have to be torn off. So when you compare it to other type of products out there for single ply, metal roofing, urethane, all these products have to be replaced at some period in time. And so this slide kind of shows you that ours product never has to be replaced, and what traditionally some of the other roofing type products may. Single ply every 20 years, metal roofing 30 years, urethane coatings 15, bitumen 15 years, acrylic coatings 10 years, and maybe reapplied depending on the application, and then tar and gravel every 15 years.
And you've got a key word here, namely landfill. If you follow the proceedings of the City Council at all, they continually call for a relocation of our landfill, which is currently up in, that's another Waimanalo Gulch, as you're rounding the curve from the Kapolei area into the Waianae coast. You just go up a dirt road, and that's where the landfill is. And they want to relocate it because of complaints from the neighbors. Now, where in the world are we going to relocate a landfill on Oahu?
Not likely.
I
I think I've seen some issues where people have actually had to, when they vacate a property, put it onto, a container or something and have it leave the island. Because there is so much product being removed.
And of course, that's free, right? That's
No,
a joke.
it's very
It's not
expensive.
free. It's very expensive, yeah. So this product is going to be resource efficient and reduce our need for more landfill space. And on that very cheery note, we need to take our second break. Code Green, Think Tech Hawaii, back in 1 minute.
Hi, I'm Jay Fidel. I'm host of Hawaii, the State of Clean Energy, which is our flagship show, which plays 4 to 5 p.m. every Wednesday. And the supporters of that show are Hawaii Energy Policy Forum and Hawaii Energy. And luckily enough, we have representatives of both of them right here today to tell you more about what they think about the show. Sharon Moriwaki at my left is co-chair of Hawaii Energy Policy Forum, and she goes first. Sharon?
Thank you. Thank you, Jay. I'm so glad that we have this Hawaii, the state of clean energy. This was 2 years ago when we started this, and we have continued it because it's so important, and there's so many developments happening across the state. And we hope you'll tune in every Wednesday, 4 to 5. It's wonderful.
And Ray is Hawaii Energy. Ray, what is your thought about the same subject?
Well, I agree completely with Sharon that we are talking about every Wednesday, 4 to 5. We talk about some of the most important subjects that are affecting the islands now and into the future. Energy, clean energy, we need it. We often run into new ideas that we had not thought about before. We did just today, and I think we're going to have more of that in the future. So come on down and watch us 4 to 5 on Wednesdays, and we'll see what happens.
We'll see you then. Aloha.
Aloha.
Good afternoon again, Howard Wigg, Code Green Think Tank Hawaii. Have as my honored guest today, Michael Hallinan, Director of Sales, Pacific Industrial Coatings. This type of stuff here, very, very, very important for reducing the energy use in our homes and in our buildings, and incidentally, I want to point out, comfort.
Yes.
If you don't have a well-insulated home or building, you have heat pouring through, and then you have AC turned up full blast, so you've got a heat source over here and a cold air blasting you over here. You are not comfortable, and you're not healthy, and you're not productive. I can cite study after study after study. But we have some more fascinating slides to view here. The size of the HVAC, that's the air conditioning system, is something I want to point out. People say with the energy code, things like this, oh, but it raises the cost, it raises the cost. What happens when you can reduce the size in new construction or renovation of your AC system by 30%? Not only are you going to be saving energy in substantial amounts, the size is going to go way down, and then there's something called ducting. You have to duct all this cold air and take it out again. The smaller the HVAC system, the smaller the ducting system. So you save all over the place in new construction.
Exactly right. So that pretty much covers that slide right there. Looking ahead, the spray foam installation versus fiberglass. This was a study that was done in Texas, and this was a house that they put both the spray foam insulation as well as fiberglass side by side. And the outside temperature ranged from 34 degrees up to 104 degrees over 10 months. And after both products were applied, the interior space on the foam side maintained about a 75-degree level throughout the year. Average electric bill was about $96, certainly probably quite a bit less than what we pay here in Hawaii. But over the 5 months, the electric bill saved over $547.56, and able to use smaller HVAC system due to the tighter seal and less air loss in the space. Comparing that to fiberglass side, the interior foam, our interior ranged from 65 degrees up to 85 degrees, so they had quite a temperature flux. Their average bill was about $205, and it did cost them $547.56 over the cost of the utility for a house that had foam in it.
Yeah, this is an eternal debate that goes on within the construction industry. Now, foam's good, but it's so expensive. So I just in all fairness, I'll have to have a fiberglass person come in and do a rebuttal here.
Yeah,
but I happen to know that the most efficient homes that are going up on this island, and I presume maybe the neighbor islands, they do get a foam treatment, and their energy use is really, really, really low.
Yeah, I know that
Yeah.
Gentry Homes is a big advocate for the interior foam in their new construction, and they've been doing great, so that might be somebody you might want to chat with a little bit comparison to what they were doing when they did regular installation.
Yeah.
D.R. Horton is still on the regular installation side, but they're starting to convert back to an interior foam because the energy savings is just so dramatic.
Yeah. And then that becomes a marketing tool also. Look at how low your utility bill is going to be. And therefore you have more free cash. You can pay your mortgage or do anything else you want with it. Pay down your debts. What a concept, yeah.
Exactly.
Yeah. So what else do we have here?
So the next slide, basically going over the differences between the spray foam insulation and fiberglass insulation. One of the bigger things that we notice is the bugs don't like the spray foam insulation, so that it keeps all that outside out and what you want in the home. Higher energy savings, lower utility bills, estimated payback within 5 to 7 years faster than what the additional cost that the spray foam might cost, and fiberglass can be replaced in 5 to 7 years with the savings that you'll achieve with it.
And I see an Energy Star logo there. Maybe I'm more familiar with Energy Star than you are, yeah. And energies in any energy using appliance or technology, the Energy Star is a national program sponsored by U.S. Department of Energy, and they rate all of the products offered in the technology, and the top 20% of whatever it is reaches, and this is independently tested, reaches an Energy Star label. So just a little pitch for Energy Star in general. You want to save energy, you want to keep money in your pocket, do Energy Star. Oh, and we were talking about Hawaii Energy, which is one of the major sponsors of this program. They will give a rebate, say if you buy an Energy Star refrigerator or washing machine, or how about an Energy Star roofing system?
Yes, that would be
Yes.
great to see that
Well,
come across in some kind of credit in the future.
Well, didn't you say that they do? Hawaii Energy does.
Rebate,
yeah.
they do have a slight rebate on the roofing side, so that
Yeah.
that is there and available. I was also talking about the next system we'll be talking about, which is the solar hot water side. That's where we also have that product's been through the Hawaiian Energy Efficiency Program.
Yep. And we will just be looking at.
Yeah,
What in the world is this?
we
Oh,
had-
this is a detailed analysis of.
the R value, ability for the insulation to resist heat flow. Basically, just because it's an airtight vacuum, having the product applied, we don't lose as much heat through the foam as they would on fiberglass insulation. So it's just more effective than having something that allows air and other things to come in and out of the house, being that there's gaps in the insulation and not truly sealed. So the next slide is the one we were talking about, that I was talking about, the Hawaiian Energy Efficiency Program, which is a different type of collector. It's called a Soulcraft ICS product, integral collector storage system. It's passive, which means that it doesn't need a pump, doesn't need a controller. Basically, you have water pressure fillet, 3/4 inch copper pipe feed to the roof, a 3/4 inch copper feed back to the existing source that could be a 80 gallon, 120 gallon, or even a tankless gas or some kind of tankless system. Basically, when you turn on your hot water, it allows the water that's being collected in this particular unit to be brought down into the home or into the business and allow that heat to be transferred into that storage unit, and then it'll be applied to the house. We see quite a bit of gain in 80% or more heating costs of heating hot water because it's preheated on the roof. It's going to be stored quite a bit hotter on the roof than it would be in the closet or somewhere down below that has to be reheated electrically or with gas. And up to 30% total energy costs can be achieved in the home by eliminating the hot water heating component of the home. In some of the natural averages, 40% or more of the house utility bill is what it takes to heat hot water. So we have a couple units out right now, one of them in Wahiwa, and it's saving that particular homeowner about $100 a month. They have a 40-gallon unit down below with this unit actually can hold 51 gallons of water on the roof, and added to the 40 gallons they have is 90 gallons, and they just recently had a couple extra house guests join them, so now they have 6 people in their house, and this collector and the 40 gallon is more than ample enough to heat the home, and it seems the more demand it happens on the system, the bigger the savings.
Yeah, the larger the household, the greater the demand for hot water, the more effective a solar hot water heater is. Generally, if it's a retired couple and their kids or grandkids don't appear very often, we say, well, maybe not such a good idea, but when you're having a full family, and especially a large family, solar water heating is it. And I'm gathering this is what's called a passive solar system, meaning that most solar water heaters need a little pump to pump the water up from the ground level up to the roof. In this case, is that it's water pressure that does that. So if the electricity were to go out, would you be able to at least have hot water in the darkness?
As long as you have water pressure, you have hot water. So that's a very unique system, and the fact that no matter pretty much any condition that happens, as long as you have water pressure, you have plenty of hot water. And this next slide really shows well what it looks like, the water being fed into the collector, building heat and coming down hot. So it again, it's going to be stored quite a bit hotter because you don't need to have what you described earlier as a differential controller between the tank temperature and the collector temperature. In a traditional system, whenever they vary by 12 degrees, that pump is told to start. And it transfers the heat takes the water, transfers the heat from the collector down into the tank. When they get within 4 degrees of each other, that pump's told to stop. So they have a handshaking that goes on and off throughout a period of time to bring the temperature up to about 120. And in our system, this particular tank can go quite a bit higher than 120. So you're going to be bringing that down into your lower tank and heating that up very quickly and not needing to use your backup system as often.
And we need to close, but let me close by saying that the hotter the solar water heater, the less hot water you need, because you want to, what do we take a shower at, like 95, 105 degrees, something like that? Or
120
maybe 110?
is ideal. Well, I mean, your actual shower, 110.
Oh, yeah, with the water you're getting on you, because my point is
sorry.
you're mixing the cold with the hot, and the hotter it is, the less hot water it is. So on that cheery note, thank you very much, Mr. Michael Hallinan, Director of Sales, Pacific Industrial Coatings. This is definitely an important path to achieving Hawaii's Clean Energy Initiative. Thank you very much.
Thank you for your time today. Mahalo.